Okay, so we're going to look at some examples that look at either compound interest or present value. So just to review, present value looks at solving for the principal amount. Compound interest looks at solving for the accumulated amount. And so what we've noticed so far is that the more frequently interest is compounded, the more in interest you will earn over time. Okay, so if you have interest compounded on a monthly basis versus interest compounded on an annual basis, obviously the one where your interest is compounded monthly will give you more money over time, a greater accumulated amount over time. Okay, so let's look at example 5. So we have Lyanton wants to have a total investment of $8,000 in 6 years with interest compounded semi-annually at 7% per annum. How much does he need to invest initially? So let's take a look at what information you're given. So Lyanton wants to have a total investment of $8,000 in 6 years. So what that tells me is this amount that's given is actually the accumulated amount. That's how much money he wants to have in a span of 6 years. Okay? What we don't have in this case is how much money he's invested initially. So we don't have the principal amount. And if you read the last sentence of the question, it says how much does he need to invest initially. And so that means we need to figure out what the principal amount is. We don't know what that is. Okay? We're told that it's compound interest because it says compounded. Okay, so we know we're going to be using the compound interest formula. We may need to rearrange it to solve for the value of the principal amount or the present value, which is not a big deal. One of the things you want to notice is what kind of interest you're trying to solve for. And because we know this is compound interest, I'm going to start with the compound interest formula and then plug in the information we know from there. So A equals P times 1 plus I to the exponent n is what I'm looking at. And so because I'm solving for the principal amount, I can rearrange this equation now. Notice that I didn't memorize what the present value equation was. I can rearrange the equation to actually solve for it. So I'm going to rearrange the equation now. And so to get P by itself, I need to divide both sides by 1 plus I to the exponent n. And so I get P equals A divided by 1 plus I to the exponent n. So now let's take a look at the information that we know. We know that the accumulated amount that he wants is 8,000. Okay? Let's take a look at the interest rate. And so you're told that the interest rate is 7% per annum, so 0.07. And we're told that the interest is compounded semi-annually. So that means he's earning interest twice a year. Okay? So the actual interest rate per compounding period would be 0.035. Okay, so we're going to be using this number. Okay, the number of compounding periods. So, because he's investing for 6 years, and he's investing in an account that's giving him semi-annual interest, so that means he's earning interest twice a year for 6 years. And so that means he's earning interest 12 times over a span of 6 years. So there's all the information I need. I'm going to substitute it into the equation. And I get 8,000 divided by 1 plus I, so 1 plus 0.035 is 1.035 to the exponent 12. And because I have all the values on the left-hand side of the equation, I can type it into my calculator and get the answer in one shot. So I have 8,000 divided by 1.035, and notice that I put 1.035 in brackets, to the exponent 12, and that equals $5,294 and about 27 cents. Okay, and again, you're looking at money, so you want to round to 2 decimal places. And this quantity makes sense because he should have invested less money so that 6 years later he has more money. Okay, so that makes sense. So therefore, Lyanton must invest about $5,294.27. Now, if the question also asks you for how much interest he earned over time, you can solve for the interest because all you're really looking at is the difference between the accumulated amount and the principal amount. And so the accumulated amount in this case is $8,000. That's how much he wants to have. And the principal amount that he needs to invest to get that much money is $5,294 and about 27 cents. And so the amount of interest he would have earned over that much time is a total of $2,705.73 in interest. That's pretty good. Okay? And so that's if he's investing at an account that pays 7% per annum, and the investment is giving him interest twice a year.